Good evening. The international scientific community has released an unexpected and impressive result this week. An interstellar comet known as 3I Atlas has revealed traces of two substances that immediately caught the attention of researchers, nickel and cyanide. The announcement was made after light analysis emitted by the comet's tail showed chemical signatures compatible with these compounds. To the general public, this may seem like just another astronomical finding, but for those who study space, it is a rare and highly significant discovery. 3I Atlas is a visitor that does not belong to our solar system. It came from elsewhere, from some unknown point in the galaxy, crossing the void for millions or perhaps billions of years before intersecting our path. When an object like this appears, every piece of information it provides is treated as a valuable clue. After all, it carries within it data about regions of the universe we may never reach directly. And now, by discovering that this comet contains cyanide, a substance often associated with toxicity and industrial poisons, and nickel, a metal found in the inner layers of denser planets and asteroids, scientists are faced with an intriguing question. What exactly was this comet before wandering alone through space? Cyanide, despite being lethal to us, is relatively common in space. It has been detected in nebulae and even in smaller comets. But the way it appears in 3I Atlas suggests that it is not just simple chemical residue. Its presence is consistent, well distributed, implying that it may have formed under specific and possibly violent conditions. Nickel, on the other hand, is typically associated with materials that have undergone intense processes, such as melting and pressure. This leads scientists to speculate that 3I Atlas could be a fragment of a planet destroyed in another solar system. Imagine for a moment that the comet now crossing our stellar neighborhood was once part of a planetary core, a solid body with crust, atmosphere, and perhaps even oceans. For some reason, a collision, an explosion, or some large-scale cosmic event, that planet was fragmented, and one of its pieces was hurled into deep space. It wandered alone for ages until now. And now, as it is observed, it reveals traces of that ancient history through these two elements, nickel and cyanide. The presence of these substances also raises a parallel question. If the comet contains materials that could be dangerous to life forms like ours, does it represent any kind of threat? The answer, according to experts, is no. 3I Atlas is merely passing by. Its trajectory poses no risk of collision with Earth. Furthermore, the amount of these substances is small and diluted in dust and vapor. There is no possibility of contamination. Still, the discovery serves as a reminder that beyond Earth, the universe is not only beautiful and silent, it is also chemical, reactive, and in many cases hostile. Interstellar comets like this are extremely rare. Until now, only two others had been confirmed. The first was detected in 2017 and became known as Oumuamua, a mysterious object with an unusual shape and behavior that is still debated today. The second was Comet Borisov in 2019. Now with 3I Atlas, the list gains a new member. Only this time, with a more direct and scientific revelation, it contains substances that tell a much richer chemical story than previously imagined. Researchers state that discoveries like this help us understand not only where these objects come from, but also how matter organizes itself in the cosmos. Elements like nickel usually concentrate in the inner regions of rocky planets. Cyanide, when combined with other molecules, can form even more complex compounds. Thus, by observing a simple chemical trail left by a comet, scientists can reconstruct events that may have occurred billions of years ago in solar systems completely different from our own. Now, an even more important question arises: why are the cyanide and nickel found in this comet of such interest to scientists? The answer may seem contradictory. Although these substances are dangerous to humans, they may also have played a fundamental role in the emergence of life. Laboratory studies show that compounds derived from cyanide can, under certain conditions, participate in the formation of amino acids. And amino acids are the basic building blocks of proteins. In other words, on a cosmic scale, what we consider poison may, at the same time, have been an ingredient for life. Nickel, meanwhile, plays an important role in certain biological reactions. There are theories suggesting that billions of years ago, on early Earth, nickel present in rocks could have catalyzed chemical processes that led to the formation of the first organic molecules. So when scientists observe an interstellar comet carrying these two elements, they do not see only danger. They see possibility, the possibility that life in its simplest forms may not have originated only on Earth. Perhaps it was prepared in space, cooked over millions of years inside fragments of rock and ice like this comet. This theory is known as panspermia. According to it, the fundamental building blocks of life can travel freely through the universe, trapped inside comets, asteroids, or cosmic dust. When they encounter a planet with suitable conditions, liquid water, stable temperature, a moderate atmosphere, these blocks can initiate reactions that lead to life. Perhaps this is how it happened here. Perhaps it is happening elsewhere now. Scientists are cautious when discussing this hypothesis because it has not yet been proven. But discoveries such as this one in 3I Atlas strengthen the idea that life may be a universal phenomenon, not exclusive to Earth. If a comet coming from so far away carries substances that could form essential molecules, then there is a chance that others do as well. And if they intersect with young, warm planets as Earth once was, the process may repeat. From now on, new telescopes and space missions may begin focusing more effort on searching for specific compounds in interstellar objects. The cyanide and nickel found in 3I Atlas are not just laboratory data. They are chemical messages sent from another part of the universe. Messages that say, there is activity, there is movement, there is transformation. The universe is not static. It is made of stories being told, even when there is no one to listen. To the average citizen, this may seem distant. After all, while we look to the sky, our concerns remain down here. But it is precisely by looking up that we better understand who we are and where we came from. Each new discovery like this one reminds us that life is fragile, rare, and at the same time possible in many places. A comet with cyanide and nickel may seem dangerous, but it is in reality a messenger, a reminder that we are part of something much greater. And so as 3I Atlas continues its silent journey, crossing our solar system and slowly moving away once again, it leaves behind not only a chemical trail, it also leaves a question: are we alone? Or are we just beginning to hear the first answers?